Hey guys, welcome back to a new edition of SynapCores, learning how to do vector search using the system's done-for-you recipes. Um, so if you click on the left panel on recipes, you can navigate and search for Semantic, and you will see there several recipes that actually exercise the semantic capabilities of SynapCores unified database, right? So we're gonna do a quick one. And you have plenty of recipes to look for. The one that we're gonna be using is document search, which is right here. If you're actually doing follow along, I'll give you a couple of seconds to get all caught up. Put up your instance and open the interface on localhost. And you're going to see that we're going to actually run one by one. So actually, really important here in the UI interface, if you see the run command and the copy command, those actually allows you to execute. If you can see right now in the UI, we don't have any other database on any tables in the database. The ones that we have is the one for OpenClaw, the memory, and three other tables that I have there that I was actually playing around with some of the features on it, right? So the database is mainly empty, specifically for this demo. So let's get to it. Let's do semantic document search. So the first thing we want to do, we want to scroll in. You can read the descriptions on it. It tells you what the recipe does, what's the objective, and then it guides you step by step in each section of the recipe to get just there. If you want more information on the recipes, you can click on information. You can see all the tags, description, and then you can actually copy the recipe. This one I actually imported, copy the recipe, download it. You can actually share to one of your coworkers if you guys are working on the project, or automatically deploy it to the system. And then, if you click the deploy, you will see that information there. Different click and deploy that what we're going to do right now is we're going to use the UI execute button to execute the SQL commands here, so we don't have to go back and forth in the query. You see, I just click on it and I created a table. So that table created right now, 2 milliseconds, right? So now we're going to create the next table. We're going to click on run again, and that will create our next table. When you see that, done. We're going to actually create this one here again, create another one, run. So these are just a schema table. So this is the tables that are going to house the information for our exercise. No magic yet. Now we're going to insert the sample documents, right? So in this case, they're all transcribed into text. I inserted all the text document. There are 10 records in there. And now where the magic begins. We're going to create what we call the vector table. So we're going to do the embedding, right? So we have title embedding and summary embedding for those document titles. Now I'm going to insert document chunks, which is actually pieces of those documents. So in those tables, that's done. And now we're going to do the first semantic document search. What are we doing? We tell the system to select all the records, right, that are relative to the meaning working from here guidelines, right? Then the columns, it's going to list the code, title, summary, category, department. And then if you actually see what we're looking for is working from home, guidelines and requirements, right? And it's relevance. So the last column is going to be how similar is that phrase to the document is going to list in those columns, right? So it's basically a scoring factor. The higher the number, the more similar is the string to that document, right? So we can execute it. You see here is the SQL select statement, give me all those documents, provided 3 or 5 documents. And then the last column, like I was telling you, is the score mode and the relevance. How relevant is the topic near to that document, right? So in this case, the first one is the highest document that's more relevant, which is the remote work policy, right? So if you're the developer and you get this data via an API result set, obviously the data is returned automatically. You sort it by the most top high relevant document. I would just pick that one, right? And then you extract the document by ID, right? If this would be kind of like, okay, a recommendation engine where you're going to recommend several documents, you pick the top 3, right? Now we're going to search with document chunks, right? So it's kind of the same concept, password security authentication. We run, and then and the last column you're going to have the relevance of the documents, right? So if you actually look closely, let me scroll here to the left for a second. The most relevant document is the one that has actually makes reference to password security and authentication, right? Category scope search is basically in SQL. We have the work clause where we tell him, hey, I want you to only search to all the documents that are within the category of HR, right? That's the straight SQL statement. Nothing magic there. My apologies for that phone call. And then if we click in here, we are going to able to look for anything similar to employee benefits and compensation. And there you have it. So the first document, which is the most relevant, is the employee handbooks of 2024, right, within policies, right? Because we're looking for employee benefit and compensation. Find related documents. If the tables were indexed, this should actually give us some results, right? And I'm telling him which documents were going to actually be related to it, and it gave me some similarities, some specific documents there, right? We can actually log searches and create transactions on it. This is what this SQL is doing. I'll give you an example of how to do that. And then we can actually build document relationships. So that's the query right here. That's the Geo0 records. And then we can do search analytics, right? Document recommendation. This is kind of like nearest neighbors. There's no recommendations that you found. That's probably kind of index. And then the cleanup optional. So if you're playing with this, like I just did, and you don't want to leave those tables hanging in there, as you can see in the database, now we have those 4 new tables that we didn't have before from the exercise we just ran. The best thing you can do is just to run the cleanup queries, and those tables will get deleted. If you're working on a project that you want to use those schemas because that's actually similar to the project that you're working on, then what I'll suggest is on the recipe side, let's go back there for a second, just run the schemas. I'm going to go back here in the recipe. Let me look for Semantic for a second. Oh, sorry, no recipes, semantics. Sorry about that. Let me put this up again. All right, so if you run these ones here, right, which is your table schemas, do not run the other one. Like step 5, I'll skip that one, skip step 7, which that's actually injecting data, right? And obviously, you can run the embedding queries until you have data on your application, right? Which you can do actually later on. So there you have it. If you need more recipes, you can actually click on Browse Online Recipes. Those are actually the ones we post online on our servers every week. We actually come up with new recipes. So you can actually import them directly in the UI. You go in there and you can actually click on any of the recipes, like let's go in here, pharma. And then you could click import, and that will basically bring the recipe to your platform, right? It will actually check and validate the recipe to make sure there's no code injection in it, protect your system. And if that's so good, you click on run, and then you actually have the recipe inside the platform. Guys, I look forward to see you next week. Next week, we're going to be doing auto machine learning or auto ML, what we call that. Very excited to actually introduce to you guys that functionality.